Geometry, Chapter 3, Lesson 5, we're going to look at the polygon angle sum theorems. Notice that word is plural, so we'll be talking about a few theorems. And we're going to be talking about polygons. And we talked about triangles in the last lesson, and now we're going to apply some theorems to polygons. So, like triangles, we'll want to determine what kind of a polygon we'll be working with. So we want to learn how to classify those, and then we'll take a look at the theorems. So let's go ahead and take a look at how do we classify polygons. The first thing we want to know is what is a polygon, what makes a polygon, and so this definition is in your book. And it says a polygon is a closed plane figure. So let's take out the key points here. So it's a closed plane figure, meaning it's closed, there aren't any openings. It has at least three sides, so a triangle would be three-sided, so that's the smallest type of polygon. And the sides are segments, so this eliminates circles and ellipses and those types of things because the sides of those are not segments, those are curved arcs. So we're only looking at figures that have segments as their sides. A couple other things, it says the sides intersect only at their endpoints. So there's only one intersection where the two sides come together, so they can't cross in another place. And then no adjacent sides are collinear, meaning you can't have one side and then another side on top of it. So you can't go forward and back and call it a polygon because you have they'd be on the same line. So if we break that down and put that in our notes, definition-wise, there's really these 4 or 5 characteristics. Number 1, it's a closed figure. Number 2, it has to have at least 3 sides. Number 3, the sides have to be segments. Number 4, they can only intersect at their endpoints. And number 5, the adjacent sides cannot be on the same line. So when it comes to classifying or determining whether a figure you're looking at is a polygon or not, you'll want to go through these 5 things and just check them off like a checklist. And if any one of these is not on the checklist, then that figure is not a polygon. So, for instance here, let me try to, let's see if I can't move this down, kind of get it out of our way. Kind of try to do both here. So here's our figure right here. If we're taking a look at this one, is it a closed figure? Yes, it's all closed. Does it have at least 3 sides? Yes. Are the sides all line segments? Yes. Do they intersect only at the endpoints? Yes. And are none of the adjacent sides collinear? Yes. So therefore this first figure here would be a polygon. So again, you just go through that checklist and that will help you determine if it's a polygon or not. What about this? Is this a polygon? Is it a closed figure? Well, no, this is open. You could go walk right inside here. So because it's not a closed figure, I don't have to go any further. It's not a polygon because this condition or this requirement as part of the definition does not fit for this diagram. Here, what about this? Is this a polygon? Well, again, let's go through our list. Is it a closed figure? Yes. Are there more than 3 sides? Yes. Are the sides all segments? Yes. Do the sides intersect only at the endpoints? Well, no, because this side here intersects with this side here, and that's not an endpoint of either segment, so therefore this is not considered a polygon because it does not meet this requirement that it must intersect only at its endpoints. So again, keep these 5 things in mind, make them a little checklist, and then check those off if you're trying to determine if the figure is a polygon or not. Well, now that we know what a polygon is, how do we name these polygons? Okay, we name angles a certain way with an angle symbol and then 3 letters if there's multiple angles or 1 letter. Segments, we have a way to name those. Rays, we have a way to name those. So everything has a way to be named in geometry. So how do we name a polygon? And it says here that we can start at any vertex and then we just list the vertices consecutively either going clockwise or counterclockwise. So you can name it in multiple ways. So you start at any vertex. Let's start at B, and I could go all the way around. So I could go B, D, H, K, M, G. That would be one possible name. Or I could start at B and go the other way, counterclockwise. B, G, M, K, H, D, and that would be another name for it. So it doesn't matter where you start, and it also doesn't matter which direction you go, but they do have to be consecutive, and you do have to list all of the vertices. So every vertice must be listed, no shortcuts. So however many vertices there are, that's how many letters will need to be in the name. Okay? Now the nice thing about this is once we have that, we can name the angles and the sides. So if we were, let's say we started at B, so this would be, let's go clockwise, B, D, H, K, M, and G, this would be the name of this polygon here. Now what would be the vertices? Well, the nice thing about putting them in this order is that each of these letters is a vertex. So you have a B vertex, a D vertex, an H vertex, a K vertex, an M vertex, and a G vertex. Each one of these is a vertex. So to identify the vertices, you would just simply list those. So you would have B, well, let me just go here. You'd have vertexes, let me label this, vertices would be B, D, H, K, M, and G. So those would be the vertices. Now what would be the sides? Okay, and the nice thing about listing these in alphabetical order is that every 2 consecutive letters make a side. So these 2 letters is one side, so that would be segment BD, and then the next 2 letters would be another side, DH, segment, and then the next 2 letters would be the next side, HK, then the next 2 letters, KM, and then the next 2 letters, MG, but then don't forget you have to go the first letter and the last letter would also be a segment, GD. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Notice that the number of vertices and the number of the sides are the same. Then if we wanted to list the angles, like I said here, the nice thing again about putting this in order, whoops, I don't want to erase everything, I just wanted to erase this part, would be that these are also the angle measurements because there's only one angle at each corner. So my angles, let me put this over here. The angles then would be angle B, angle D, angle H, angle K, angle M, and angle G. So once the name is in order, you can pretty much use the name to list all the vertices, all the angles, and all the sides. So isn't that nice? That's nice when we do things like that in math because things just all are in order and they're nice and easy to figure out. Now notice that the number of vertices, the number of angles, and the number of sides are all identical. They match the number of sides of the polygon. Okay, so we'll talk about how to name these a little bit later. Okay, so that would be that. So I think we'll wrap this up here. On the next video, we'll look at how you classify and look at concave and convex polygons.